We performed some serious braking tests, conduct a complicated science experiment, and have an epic race.
Hello, and welcome to the Top Gear Young Driver Safety Challenge Race Challenge. Today, more and more young people are getting behind the wheels of their cars, going out into the public streets, endangering all of our lives. It's inevitable. I mean, hey, they just learned to wipe their butts, might as well give them a car, right? So what we've done is assembled 3 cars that we believe best represent the purchases that young drivers are going to be making. Safety may not be at the top of their list of priorities, but it's still important. So in one corner, we have a 9-year-old Honda Odyssey minivan, a party van for the party man, perfect for young people. In this corner, we have an 8-year-old Subaru Outback for the outdoorsy and the adventurous. And in the middle, we have a 2-year-old BMW 328i for the rich people that just don't know what to do with their money. Hey, shut up, Dennis. Strap in and get ready, because this thing is gonna blow up.
So for our first test, we're going to drive our cars up to 25 miles per hour, and when we cross a certain line, we're going to slam on the brakes and see how long it takes to stop.
And we begin. That's 25, and stop. Proper stop.
No.
See, the thing about Subarus is they last forever. Even when you're doing really, really stupid stuff. In the name of science. For those who don't believe me, I encourage you to check out Subaru's World Rally Championship history. Come on! What kind of scientist is he? Don't get a break. Alright. That's 25. And break. 34 feet. Alright, looks like we're staying pretty consistent.
Alright. 2 more?
2 more. You know why they call this car the Subaru Outback?
Why do they call it the Subaru Outback,
Because
Khasan?
it takes you out back and kicks your ass.
Good one, Khasan.
Nailed it. RPM, 25 miles an hour. Don't squeal your tires, alright?
Yeah.
And we're off! Gonna do a nice, calm 25 miles per hour. And stopping.
29? Alright.
What? Gentlemen, rev your minivan engines. And we're off. A fantastic launch on a dreary day. Just what we needed.
Very nice.
25 miles per hour. And... Whoa, 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 yeah! Front wheel drive tire squeal. It's hot. Who says vans aren't fast?
They do call this
Real
the
men love vans.
woman van, you know? It just attracts women. People say cars are nice for picking up women. But how many women can you fit in a car? You can fit 4 at best. Do you see this? 6 woman. 6 woman. That's how you do it.
20 if you tie him up.
Exactly.
Ready? GoPro shot. GoPro.
Do it.
We are good to go. Oh,
32. All right.
that's a
How many
mark.
counts do we have left? BMW cannot.
Oh, there appears to be a electrical issue of some sort. Comment. Oh, and it's off.
There we go.
So you know this car has 4-wheel ventilated brakes, right? This should be good. Oh my God!
I believe that is about 74 feet.
74 feet.
74 feet.
All right.
Oh. Yes.
Yes.
Yes. That is what
Science
the data
does not
says.
lie.
Science.
Carry on.
The modern family car isn't good enough. But this is a good demonstration of why BMWs are really not what you want to be safe.
The garbage.
Yeah, look at this. 74 feet stopping distance at 25 miles per hour. Compared to 33 on your Subaru and about 34 on the Honda Odyssey.
Ridiculous.
It's not safe.
Have you seen those headlights? They're so blinding.
That's a hazard.
Oh my! We have a deep, deep problem here. Oh heavens.
230!
230, hang on.
Could have killed a small child.
Imagine.
Oh, no.
Think of the turtles.
I think we need to rethink this test.
And the contemporary. Come in this week and try the marinated flank steak salad with Boston bib lettuce and baby arugula, roasted corn, capers and gorgonzola cheese, topped with the red wine vinaigrette. Or enjoy buttermilk marinated Statler chicken breast with a jalapeno corn coulis and roasted garlic cheddar mashed potatoes. And if you are in the mood for fresh seafood,
Welcome back. Now, chances are, as a 17-year-old, you're gonna want to modify your vehicle. And based on what I've seen so far, most 17-year-olds, like idiots, blow a ton of money on brand new wheels as soon as they buy their cars. Often the wheels cost more than the cars themselves. But regardless, when you swap your wheels, you have to know how many lug nuts each wheel is gonna have, right? So today, we're gonna conduct a very scientific test to make sure you know exactly how many lug nuts your new, used car is gonna have. Now, the only person we're missing is James May. So let's see. Where is he?
That's weird.
What?
I just got off the phone, and the last thing he said was, I'm in a van with a bunch of little girls. And then he hung up. That's all he said.
Anyway, James May will be missed, but it's time to move on to our experiment. So, what we're gonna do now is count accurately, slowly, strongly the amount of lug nuts on our wheels. Are you ready?
I am.
Alright, start counting. 1, 2, 3, 4, 5. Hey, mine had 5.
Mine did too.
Seriously?
Yeah.
Oh, that's awesome.
Let's try a different wheel.
Alright, yeah, we need to do that. Whoa, how many did yours have now?
5 again.
That's crazy. Mine did too. I think we're onto something here.
We are.
We need to check this out though.
Yes. Let's check again.
Alright. Hello, and welcome to the final part of our Top Gear Young Drivers Safety Challenge Race Challenge. This challenge now deals with speed. How fast your car is has always been a very important part when comparing vehicles. No young driver wants to be humiliated at a stoplight. So what we're going to do for this challenge is assemble our new used cars and have an epic race. And it appears that my rivals have arrived.
I won! No, I won! What are you talking about? I won! I clearly won! What? No!
That was so mean.
No way! Your car's a piece of crap!
Your car's a
You
piece
see
of
all
crap.
this
Your
damage?
headlights are freaking yellow.
Your headlights are broken!
I won!
This isn't even an argument!
Hey, your BMW sucks.
No,
Get over
I
it. All
won.
right, no.
Everyone knows
clearly
BMW
won.
sucks. This is even worse.
No.
And back to the
Hey.
studio.
That's my line. That's my line. Back to the studio. Get out of here.
No.
I think we should.
Hello, and welcome back. Now that we're done with our testing, we're going to perform some analysis to get you some actual results. And for this, we're going to go to this book, particularly chapter 23, Inferences About Means, to get you some actual real-world usefulness. So, now that you have some inference testing skills, we're going to take it to the next level and start discussing means. So when you're performing inference testing and creating confidence intervals for means, you use a Gosset's or a student's t-model. You do not use a normal model. That is a different distribution. When you're doing this, several conditions and assumptions apply, which you will see right over here. So the first assumption is independence and consists of three parts. First part is independence. The data values should be independent. You should be reasonable about this when you don't know where the data came from. Just think about it and use common sense because there's no actual way to test independence. Second part is randomization. The data should come from a random sample so that it is representative. Now, you might think that when you're conducting braking trials, they won't be random, but we allow our cars some time to cool down before we force them to brake again, and this is fairly representative of what you find out in the real world. You know, you're driving, you stop, you're driving, you stop. Therefore, we believe our sample is representative. Lastly, the 10% condition. The sample is no more than 10% of the population. You don't really talk about this often when discussing means, but it never hurts to discuss. Nearly normal. Now this part is probably the most important one. It states that the data should come from a distribution that is roughly unimodal and symmetric. To test this, you have to create a histogram of your data values, and then take a look at it and make sure that it is roughly symmetric and unimodal. So, that's exactly what we've done over here. These three histograms show the braking distances distributed of our three cars. So as you can see, for the Subaru, it is roughly unimodal and symmetric with one possible outlier. For the Honda, it's roughly unimodal and symmetric with nothing really to throw us off. And for the BMW, it is also roughly unimodal and symmetric. Now, you might think that this would be called bimodal, but that is not the case. Since the data values are so close, it's still considered unimodal and symmetric. Stay tuned. Hello, and welcome back to the analysis portion of our program. As discussed earlier, the two things you can do with Chapter 23 are hypothesis testing and confidence intervals. So, to begin with hypothesis testing, you first write down your hypotheses. Your first hypothesis is the null, h sub o, and it is mu is equal to whatever value you want. This is what you're testing. Your alternate hypothesis is mu, it can be less than, equal to a different value, or greater than whatever value you had up here. So those are your hypotheses. For our example with the braking tests, the null hypothesis, for example, would be a manufacturer number. What the company tells us that the car brakes from 25 miles an hour. We do not have this number, so we'll discuss that issue later. But moving on. Your second step in hypothesis testing is your model. When you do your model, you write down your assumptions and conditions, which we discussed earlier. And if all these conditions are met, you can proceed with a one sample t-test, you'll see that on your calculator, and then with a confidence interval, also known as a tinterval, which you will also see on your calculator. So, let's move on to the third step in hypothesis testing, the mechanics. So, when you have your data, you can compile it into a list on your calculator, and then what you can do is find out several things that you need to complete the hypothesis testing. Your first is your n, it's your sample size. For our particular example, n was 10, because we calculated the braking distance of the BMW and every single car 10 times. Your next step is your degrees of freedom. It is n minus 1, therefore it is 9. The third thing is your y bar. This is the mean of your sample, and for the BMWs was 27.35 feet. And lastly, your standard deviation, and it was 3.57 feet. All these things can be found through the one variable statistics program that's also on your calculator. It will literally just calculate everything for you all at once. Very useful. Now, you move on to get your t-score. This is very similar to a z-score. In fact, it's exactly the same thing, but it is applied to the Gosset's or the student's t model that we discussed earlier. So, your t-score is equal to the y bar, your sample mean, minus what you're testing, right up here, and then divided by the standard error of y bar, which is also equal to the standard deviation of the sample divided by the square root of n, which is your sample size. Once you're done with that, your calculator will either calculate everything, or it can actually draw the model for you. So, when you're doing this, if you do have a true null hypothesis, you can end up with something like this, where your mean is here, and your t-value could be anywhere on the model. After that, your calculator can calculate your p-value, which is your percent chance of the observed results happening given a null hypothesis. If the p-value is low, you reject your null, and if it's high, you fail to reject. For example, if it was low for our braking tests, we would say that if this was a manufacturer's distance rating, we would say that the used car does not stop at that distance anymore. We'd have to take a look at our results and see what happened. Chances are, our braking distances would be higher. Your last step is the conclusion. Here you literally just verbalize your p-value and explain what exactly it means, which is what I just did. So if, for example, we rejected the null hypothesis, we would say that the vehicle no longer stops at the distance that the manufacturer told us. We reject the null hypothesis. Okay? So that's hypothesis testing in a nutshell. Alright, now moving on to confidence intervals. Something we can actually do because we do not have null hypotheses for our vehicles. Oh well. So for means, confidence intervals are t-intervals, and we call them tintervals because we can. Now you already know what a confidence interval is, so I won't really go into depth with that. But for means, the confidence interval is equal to the y bar plus minus the margin of error of y bar, also equal to y bar plus or minus t star of degrees of freedom times the standard error of y bar. T star degrees of freedom comes from your level of confidence and your sample size. So, for our BMW, we did our tests with 95% confidence. And using this formula, your calculator will actually calculate everything for you. You show your work by writing this down, but then the calculator does everything for you. So for the BMW, we found that the 95% confidence interval was from 24.79 feet to 29.91 feet. So what does that mean? Well, it means that we are 95% confident that a 2-year-old BMW 328i will have a mean stopping distance between 24.79 and 29.91 feet from 25 miles an hour. That's what we tested, this is what our interval gave us, that's what we got. Okay, moving on. For the Subaru, we got that the interval was from 31.09 feet to 38.81 feet,
This number is relatively high because of the outlier we had in our data. However, we are keeping it there because outliers are still data. So, once again, we are 95% confident that an 8-year-old Subaru Outback will have a mean stopping distance between 31.09 and 38.81 feet from 25 miles per hour. And for the Honda, the Odyssey, the interval was 31.72 to 35.48. Very close, really impressive. We are 95% confident that a 9-year-old Honda Odyssey will have a mean stopping distance between 31.72 feet and 35.48 feet from 25 miles per hour. And I hope that tells you everything you need to know. Thank you.
And now moving on to our second test, the number of lug nuts on each wheel. For this, we are just doing a confidence interval. Now, since we use the same cars, the conditions are met from before. Our mechanics are exactly the same as before for our braking distances, except we're now applying it to the number of lug nuts. And for this, we're doing 100% confidence because there was no sampling variation. We had 5 lug nuts per wheel for every wheel. So therefore, we are 100% confident that a 2-year-old BMW 320i or an 8-year-old Subaru Outback will have, on average, between 5 and 5 lug nuts per wheel. Thank you, and pun cake.
And now to crown a winner. So here we have our points board of winners. So, for the braking distances, May, your minivan somehow outbraked both of our vehicles. Don't really know what happened, but you won fair and square, so that's 10 points for you. I came in second place, so I get 5. And Hammond, your BMW braked so late that we thought you went into outer space. So that's minus 150
That was
for
operator
you.
error.
You could have killed a small child.
Possibly
Or a big child.
150.
Maybe 150 children. What if you were at a bike race?
How do you come up with that number? It should be 0.
It doesn't matter.
Yeah,
Minus 150.
it's science.
Get over it.
Fine, science never lies.
For the lug nut test, my Subaru had 5 lug nuts, so that's 5 points. The BMW had 5 lug nuts. And
Actually, it had 20.
No, it did not. It had 5 per wheel. Per wheel. Stop
Okay.
trying to get extra points. And you were arrested, and we had to pay to get you out of jail, so that's minus 100 points for you.
But I gained 3 people.
You got arrested and the people were taken away from you. You didn't gain anything.
Minus
We lost
100
100 pounds
yeah.
because we had to bail you out of jail.
But I had 3 people for a little while.
No!
No.
No! You need to stop abusing your minivan rights, okay? Just stop.
They were not having
Alright,
fun.
and for the window drag race, I don't really think we got anywhere with that. So, how about we just say 30 points each and
No, if
call
you
it
watch
a-
it in slow motion, I won.
You didn't win, you have a BMW.
I won. We all know that.
You couldn't have possibly won. Your windows were huge. There's no way they can roll down as fast as mine.
And only 2 windows can go down on your car.
Yeah, seriously.
But I have vents.
Look, man, I offered you a tie.
And they don't even work.
That's part of getting
Alright, well, we're
used
just gonna
car.
call it 30 points each. That's a done deal. So, I believe I have 40 points. You have, minus 60. Not looking good for you. And Hammond, you are in a very rough spot. Jeez, I believe that is a negative 115 points.
What are you gonna do?
So with that-
Drop more points while you're at it?
I'm a winner. You want some less points? Want less points?
No.
Therefore, I win. You want a new used car with 5 lug nuts and decent braking capabilities? Buy a Subaru Outback.
If you want to kidnap people.
You don't want to kidnap people.
No, you don't. It gets you in jail.
Jail's fun.
And your
Jail's not fun.
friends have to bail you out.
Right. So,
Alright. Well,
So I guess it's a super Outback.
it is a Subaru Outback.
But that was one time.
Well, no, we did multiple testing.
yes.
Yes. So
It's science.
You do know that the only safety-related thing we did was braking, right?
And on that bombshell, have a good class.